Kossel-Lewis approach to chemical bonding. Lewis postulated that atoms achieve the stable octet when they are linked by chemical bonds. So in other words, he said that there is octet rule related to that. Atoms can combine either by transfer or by sharing of the valence electrons so that they can achieve the nearest noble gas configuration. Lewis symbols. Lewis symbols are simply the number of valence electrons around the symbol of the atom. So for example, if I consider fluorine atomic number is 9, configuration will be 2, 7. So 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. Neon atomic number 10, configuration 2, 8. So it already has its octet complete. Covalent bond defined by Langmuir. It is just sharing of the electrons to complete the octet. So it is defined as bond formed between two atoms, these can be same or different, by mutual contribution or sharing of electrons. So if you have chlorine does not exist as atomic form. The reason is it has only 7 valence electrons. So as per octet rule, it does not have its octet complete. So what should happen? Both chlorines will share 1 electron each. So now if you see, this chlorine has effectively 8 electrons and this chlorine has effectively 8 electrons. So both have octet complete. That's why it exists as Cl2. Similarly, carbon dioxide. Carbon has just 4 valence electrons. Carbon atomic number is 6. Configuration will be 2, 4. So 4 valence electrons. So what it does? It shares 2 electrons, 2 of carbon here with each of the oxygen. So effectively now you can see oxygen has its octet complete, carbon has its octet complete, this oxygen also has its octet complete. So electrons are being shared, that's why we can say that octet is complete. Similarly for C2H4, ethene, carbon has total 4 electrons in valence shell. So carbon, these two belong to carbon, this one belongs to carbon, this one belongs to carbon. So it has shared all of the 4 electrons with other 4 electrons of hydrogen and carbon. Similarly, the other carbon has these 2 electrons, this 1 electron, this 1 electron, and these are shared with other carbon or hydrogen. So in total, now each carbon has octet complete. Remember, hydrogen still does not have the octet complete, and that is exception to octet rule. Another example, nitrogen molecule. Nitrogen atomic number is 7. So 2, 5, 5 valence electrons, and you can see 2 here and 3 here. These 3 are shared with other 3 of the other nitrogen atom, and these 2 are free. So in total, if you see, this nitrogen effectively has 8 electrons, and this nitrogen also effectively has 8 electrons. Octet is complete. Another example, C2H2, ethyne molecule. Ethyne or acetylene, both names are correct. So carbon here has 1 electron, 3 electrons shared with other carbon or hydrogen. These 3 are of other carbon, and this another electron is of this carbon shared with other carbon and hydrogen. So effectively you can see within the circles, here you have total 8 electrons of this carbon, total 8 electrons of this carbon. Remember, hydrogen still doesn't have the octet complete. Hydrogen will never have octet complete. That is the exception. Here are few molecules and their Lewis representation. This will give you a fair idea how to draw the Lewis structures. The first one here, oxygen. Oxygen, if you see, has 6 electrons each, but 2 electrons each shared. So total 4 shared. Now you have 8 electrons here and 8 electrons here. Octet complete. So these two bonded pairs are shown as covalent bonds. This is sharing of electrons, so that's why covalent bond. Similarly, ozone shares the electrons in this way. You should draw these structures so that you are able to understand the problems I will be talking about later on related to resonance also. So try to understand and draw these structures. Then carbon monoxide. So in carbon monoxide also, the electrons are shared. Now it is slightly tricky to understand here. There is one specific bond in CO which is known as coordinate bond. So understand what is coordinate bond. Coordinate bond is very similar to, I'm not saying same, it is similar to covalent bond. Similar to covalent bond. The difference is that both electrons are provided by one atom, shared by both. So 2 electrons are from one atom only, but shared by both. Try to understand how it happens. In this case, these 2 electrons and these 2 electrons, these 4 are of carbon. Carbon has 4 valence electrons. Oxygen has 6 valence electrons. So to complete the octet, suppose if carbon shares 3 electrons, oxygen shares 3 electrons. Carbon has total 4, oxygen has total 6. So in this case, if you see, carbon will have 7 and oxygen will have 9 electrons. So 7 electrons, 9 electrons, and obviously it is not as per octet rule. So what happens? In this case, carbon shares only 2 of its electrons, these 2. Oxygen actually shares 4 electrons, 3 and 1. So oxygen shares 4 electrons. There are still 3 bonds here in between. These are 3 bonds because there are 3 pairs of electrons. So 3 bonds. Now try to understand how do we show it. In normal sense, as I said, coordinate bond is very similar to covalent bond, so you can show it covalent bond. But effectively it is actually C here, and this bond will be shown as arrow towards carbon. It signifies that oxygen has provided the electrons. Arrow is from oxygen towards carbon, just to indicate that oxygen has provided these electrons to carbon, shared by both. Now if you see, total number of electrons with carbon 8, total number of electrons with oxygen 8. Now there will be some positive charge and negative charge here. Why? The reason is oxygen has effectively given one of its electron to carbon. So if one electron is given, it means it will attain positive charge. It has lost negative, so it will attain positive charge. Similarly, carbon has received one electron which is negative, so it will acquire one negative charge here. I will be talking about it in another video. These are the formal charges. How do we calculate formal charges? There is formula for that, very simple formula. You will be able to find these charges using that formula as well. Next, CO2. So this is the formula you need to remember. Okay. And octet complete, we have already talked about it. Then next OF2. Next H2O2. All these structures you should draw in your notebook and try to draw yourself without looking onto the video or notes. And F3, all octets are complete. In case of hydrogen, octets are not complete. These are duplets. H2S, sulfur will have octet complete, hydrogens won't. Then PH3, phosphorus will have octet complete, hydrogens won't. SiCl4, all silicons and chlorines will have octet complete. SO3, all octets complete. HNO2, nitrous acid. All these structures draw and memorize. HNO3, nitric acid. And what are these charges? We will be calculating from formal charge formula. S3PO4, phosphoric acid. C2H4, ethylene or ethene. Both names are correct. C2H2, acetylene or ethine. Both names are correct. NO3 minus, nitrate ion. CO3 2 minus, carbonate ion. SO4 2 minus, sulfate ion. H3O plus, hydronium ion. HClO4, perchloric acid. I advise you to remember all these structures. And that's about the Lewis structures and Lewis postulate.